નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી. સ્ટેન્ડર્ડ 9th, સબ્જેક્ટ સાયન્સ, chapter 8, motion. So, dear students, today we will discuss the motion. What is meant by motion? See, when you will say the motion means what? When a body is said to be in motion, when its position changes with respect to a reference point, with respect to the reference point. So that is called as a motion. Now we'll see the explanation of the text lines. In everyday life, we see some objects at rest and others are in the motion. You know that some of the objects are at rest position only. See the stones and other things, trees, but others are in the motions, cars, vehicles, birds. See here given some of the examples. Birds fly, fishes swimming, blood flows through the veins and arteries, and cars moving. See, these are all in the motion. And other examples, atoms and molecules. See, atoms and molecules, planets and stars and galaxies, group of stars and planets. Okay, so galaxies are all in the motion. We often see an object to be in the motion when its position changes with the time. So when its position changes with the time, however, there are situations. Okay, there are some situations or incidents where the motion is referred to through the indirect influences. Inferring through the indirect influences. Some of the evidences are here, proofs are in indirect ones. For example, we see conclude the motion of the air by observing the movement of the dust. See, movement of the dust, the movement of the leaves and branches of the trees. So these are all indirect evidences, movement of the air. And what causes the phenomena of sunrise, sunset and changing the seasons is due to the motion of the earth. See, these are all caused by the motion of the earth. Is it true? Why don't we directly perceive? Why don't directly you will see the motion of the earth? Okay. Any object may appear to be moving for one person and stationary for some others. See, one person seems to be moving, but other persons it is stationary, standing position only. For the passengers in the moving bus, for example, passengers are moving the bus, the roadside trees appear to be moving for backwards. A person standing on the roadside perceives, the bus is along with the passengers are moving. So like this they are observing. Okay. However, a passenger inside the bus see his fellow passengers, the same person moving in the same vehicles, fellow passengers we are saying, are at rest. What do these observations indicate stands? So most motions are complex one. Many of the motions are complex. You are not able to judge correctly. Some objects may move in the straight lines, others may be circular path, some may be rotating, and a few others may be vibrating. Okay, just what you are saying, shaking. There may be situations or what you are saying, in situation means incidents involving the combination of these also. So in this chapter we will describe the motion of the object along the straight line. Say motions moving with the straight line objects. And we also learn express motions through simple equations, graphs, and the motions we will study with the graphs and simple calculations. So we will discuss and later last one we will discuss the circular motion. Now discuss the activity. Discuss whether the walls of your classroom are at rest or in the motion. See, you have to say. Then have you ever experienced that the train in which you are sitting appears to move? So we have observed this one, experienced, ask the question here. Okay. Now, which one is describing the motion? Describing the motion. We describe the location of an object by specifying with a reference point. What do you mean by the reference point means what? Okay, let us understand this an example. Let us assume that the school in the village is 2 kilometers north of the railway station. See, railway station is the reference point here. From the railway station 2 kilometers north side, we have specified the position of the school with respect to the railway station. Railway station. In this example, the railway station is the reference point. We could have also choose other reference points according to your convenience. So you can choose our own convenience. Any shop you can keep or any houses. So like this way, reference point should be there. Therefore, to describe the position of the object, we need to specify a reference point. So that is called as origin. O-R-I-G-I-N. So that is why origin. O-R-I-G-I-N. Okay. Now motion along the straight line. Motion along the straight line. The simplest type of the motion is the motion along the straight line. Motion along the straight way. We shall first learn to describe by this example. Consider the motion of the object moving along the straight path, straight way. The object starts its journey from O, which is treated with reference to the point as 8.1. See, let A, B, C. See, A, B, C, these are all the different stands. Refer the object at different instants. At the first, the object moves through C and B. C and B and reaches to A from the O. Then it moves back along the same path and reaches C through the B. So okay, the total length is covered by the object is OA. First of all OA, then AC. So OA and AC. So means 60 plus here to here C. Here you see that 5, 10, 15, 20, 25, 30, 35. So 35 kilometers. So 95 kilometers. So this is the distance covered by the object. To describe the distance, we need to specify only the numerical value. Only the value, numerical means numerals, and not the direction. So there are certain quantities which are described by specific only their numerical values. The numerical value of a physical quantity is its magnitude, the value. From this example, can you find out the distance of the final position C of the object from the initial position O? This difference will give you the numerical value of the displacement of the object from O to C and through A. So what do you mean by you are given here displacement means what? So what do you mean by this displacement? The shortest distance measured from the initial to the final position of the object is called as displacement. For example, so you moved from O to A, okay, 60 kilometers, then you have reached B. So then your final position is what? Where is your shortest way is only from here to 35 only. See here the examples are given. Can the magnitude of the displacement be equal to the distance traveled by an object? See, consider the example given here. For the motion of the object 0 to A, see O to A, for example O to A is given 60 kilometers, okay, O to A. And for the motion of the object O to A, the distance covered 60 kilometers and the magnitude of the distance is also 60 kilometers only. During its motion from O to A and back to B, see here back to the B you came, see here back to the B means here 5, 10, 15, 20, 25, back to the B, the distance covered is 60 plus 25 only 85 kilometers, okay. So now, while the magnitude of the displacement is only 35 kilometers only 35 kilometers. Thus, the magnitude of the displacement is not equal to the path of the length. See, the total length is different, distance is different, magnitude is different. In magnitude, you got the path, you got the 85 kilometer answer. In magnitude, this one, in the displacement, you got only 35 kilometers. So, further, we will discuss that the magnitude of the displacement of the course of the motion may be 0, but the sometimes may be 0 also. Okay, the distance covered is not 0, but in the distance it will be not 0. If we consider the object to travel back to the O, the final position with the initial position. For example, we have reached now O to A, then A to here, again U, then here displacement is 0 comes from where you started and final position what. So here this much only we are seeing. Okay, so that is why you remember that if we consider the object travel back to O, the final position coincides with the initial position and therefore the displacement is 0. However, the distance covered is different. The distance means covered in this journey OA plus A, total length only. So distance is different from the displacement. Thus two different these are both are physical quantities, distance and as well as displacement, are used to describe the overall motion of the object and to locate the final position with reference to the initial positions. Okay. So now, what is we'll see what is distance definition. What do you mean by distance? The actual path length traveled by an object is called a distance. See, the actual path length traveled by an object is called a distance, you are saying. The actual path covered by the length. So that is called as distance. It is a scalar quantity and its SI unit is meter. And it always be positive and cannot be 0. Okay, this is about the distance. And now displacement means what? The shortest distance between the initial position and the final position is called as displacement. See, from you started and finally you come here, it means again 0 only. So it is a vector quantity. It has magnitude as well as direction. In the scalar quantity, only the magnitude. Not direction will be known, but here magnitude and direction will be there. And its SI unit is meter, but small m. It can positive also, negative also, and 0 also. Okay, so these are the differences between the distance and as well as which one? Displacement. So both are displacement and distance, both are the physical quantities used to describe the overall motion of the object to locate its final position with reference to the initial position. Okay, dear students, so you got the idea of what is motion. What is motion? You told a body is said to be in motion when its position changes with respect to the reference point. See, what is motion? A body is said to be in the motion when its position changes with respect to a reference point. This is called as a motion. And what is distance? The actual path or the length, the actual path of the length traveled by an object is called as a distance. Okay. Now, what do you mean by the displacement? The shortest distance between the initial point and the final position. See, the shortest distance between the initial point or initial position and the final position is called as a displacement. And distance always positive and cannot be 0. See, distance always positive only because we are adding the total length only. But displacement means not like that. It can be have positive also, negative also, and maybe 0 also, maybe because its reference is between the initial position and the final positions. So understood, students, what is the difference between the distance and the displacement. Okay, further headings we will discuss in the next video, uniform motion and non-uniform motion. Okay, goodbye everyone. Thank you for joining us.